Chapter 4.1, Solve Simple Equations. This is the first lesson of the second unit, which is a continuation of the first unit. So let's just recall what we learned in Unit 1. We learned all about algebraic expressions. An algebraic expression is a mathematical phrase made up of numbers and variables connected by addition and subtraction operators. So here are some examples. 3x minus 4. 5x squared plus 3. These are examples of algebraic expressions. So what can we do with these expressions? Well, we've learned that we can expand out of the brackets using the distributive property. We can also collect and simplify like terms. However, we cannot solve an expression. Okay, so we can only simplify an expression. Okay, so when you hear the term simplify in math, this is what we're talking about. We'll do that right here in this example. So I'm going to distribute out of the brackets. So 5x times x, 5x squared, 5x times negative 2, negative 10x, negative 3 times x squared, negative 3x squared, negative 3 times positive 2, negative 6x. Okay, next, I collect like terms. Okay, so I'm going to put my x squared terms beside each other and my x terms beside each other, and then simplify by either adding or subtracting the like terms together. Okay, so 5x squared subtract 3x squared, 2x squared. Negative 10x subtract 6x, negative 16x. Now I've simplified. Okay, we are able to solve when we're dealing with equations. So here are examples of equations. Now, equations, how they differ from an expression are these equal signs. Okay, so remember, an expression does not have an equal sign. So we can only simplify. An equation has an equal sign. So we're able to solve. So when we're solving, what that means is trying to identify the value of an unknown variable. Okay. So how do you solve an equation? Well, we need to isolate the variable on one side of the equal sign. To do this, we need to perform opposite operations to undo the given operation. Okay, so when the variable is being multiplied, we're going to do the opposite. When the variable is being divided, we're going to do its opposite operation. When the number is being added to the variable, we're going to subtract that number. When a number is subtracted, we're going to add. So opposite. The opposite of multiplication is division and vice versa. The opposite of addition is subtraction and vice versa. Your goal is to have the variable alone, hence the word isolate, on one side of the equal sign. Once you have it alone on one side of the equal sign, you can then find its value or solve. Let's look at some examples. A, x plus 3 equals to 12. Okay, so look at the directions of the question, solve. So we're trying to find the value of our unknown x. Okay, so in order for us to do this, we must isolate it on, well, it's already on the left side of the equal sign. So let's just leave x on the left side of the equal sign and get rid of this positive 3. So in order to eliminate the positive 3, we're going to subtract 3 from it. So I'm going to write everything that's already on my left side of the equal sign. And now I'm going to include a subtract 3. And now whatever you do to the left side of the equal sign, you must also do to the right side of the equal sign in order to balance out your equation. Okay, you can't just subtract 3 from the left side. An equal sign means balance. It means that the left side and the right side are equal to the same value, or they hold the same value. So if you're going to insert -3 on the left side, you must also insert on the right side as well in order to remain or to keep an equilibrium between both sides of that equal sign. Okay, and so +3 subtract 3, well, that'll equal to 0, or they just eliminate each other. Once you do that, your x is now alone on the left side, which is what we want. And then 12 subtract 3 is 9. Let's try B, which is right below. X minus 3 is equal to 12. So I want to isolate x, which means that I need to include the opposite of -3, which is +3. So I'm going to write everything that's already there on the left side. And now I'm going to include a +3 to that side. Now, whatever I do to the left, I must also do to the right. Okay? This -3 and +3 cancel out, which leaves my x alone on the left side, which is what I want. I want that so then I can find the value of our unknown variable x, which is 15. In grade 8, you probably used a method called guess and check. We do not use guess and check anymore in high school. We solve algebraically by isolating our unknown value, or we call that a variable, on one side of the equal sign. So there's no more guessing and checking. It's just uncertainty, finding the value using this way, solving algebraically. See, 3x is equal to 12. So remember, when you see 3x together like this means multiplication. So really, this is 3 times x. But remember, we don't really use the multiplication sign x anymore to represent multiplication because it looks really confusing beside our variable x, right? This looks like 3xx, which is not clear at all. So instead, we just eliminate that multiplication sign. We just write 3x. So we understand that that means multiplication. So 3 times x is equal to 12. Okay, so the opposite of multiplication is division. So I'm going to divide 3 from my left side in order for me to eliminate the 3 so that my x is alone or isolated. And I'm going to do the same thing on the right side. So now my left side is just x, and my right side is 12 divided by 3, which is 4. And finally, this may be a little bit small to read, but this is x over 3, or x divided by 3. Okay, so remember, we're steering away from using the division sign. We're just going to use fractions to represent division from now on. So we have x divided by 3 is equal to 12. The opposite operation of division is multiplication. So I'm going to multiply both sides by 3. So this is 3 times x over 3, which means that my 3's will cancel out. Another way of seeing that is if you open up out of the brackets, Okay, 3 times x over 3. This would equal to 3x over 3, which then you can eliminate the numerator and denominator of 3's, and you're just left with 3. So I just did it in a shorter number of steps. And then 3 times 12 is 36. Okay, let's try some more examples. Solve the following equations. Again, it's using the word or the term solve, which means that you're trying to find the value of our variable. And then it tells us to check our solution, which we'll do after we complete, after we solve. So x minus 3 is equal to 2. So x minus 3 plus 3 is equal to 2 plus 3. These 3's cancel out. X is equal to 5. Okay, let's try the next one. K divided by 4 is equal to 3. So k divided by 4 multiplied by 4 is equal to 4 times 3. Next, 20 plus a is equal to 34. 20 subtract 20 plus a is equal to 34 subtract 20. Okay, so we want to make sure that we found the correct value of our unknown, or that we solved correctly. So what we do is we check. I'm going to take my ruler out so that it's nice and neat. And I'm going to draw some tables here. One here, and one here. One for each of the questions. So I'm just drawing a t-table. Okay. So we're checking. Check. We're going to check. And we're going to check. So how you label your t-table? Left side, right side. Left side, right side. Left side, right side. Okay, so the left side of your original equation and the right side of your original equation. So the left side of A, this is our original equation up here. Okay, so the left side of the equal sign is x minus 3. So I'm going to write that on the left side. And the right side is 2. I'm going to write that over here. Okay. Now we found the value for x to be 5. So wherever I see x here, I'm going to plug in the value that we solved for, which is 5. Okay, on the right side, there is no value or variable, so we can't solve further than 2. So we're done on the right side, but I'm going to continue to solve to simplify on my left side. Okay, I'm done. I can no longer simplify on my left side. My left side and my right side are equal to the same value, which is what we want. If our left side and our right side are equal, that means that we actually did find the correct value of x, which is 5. So I'm going to write since an upside down triangle. So since left side is equal to right side, therefore, a right side up triangle, x is indeed equal to 5. Let's try the next one. So the left side of my equation is k divided by 4. The right side is 3. I can't simplify the right side any further, but I can for the left side. I'm going to substitute my value for k and simplify. 12 divided by 4 is 3. Now, since my left side is equal to the right side, we did find the right value for k. Okay, and let's check for c. The left side of my equation is 20 plus a. The right side is 34. Okay, so let's focus on the left side by substituting our value for a wherever we see a and simplifying. Again, we got the same values on the left and right side. So since left side is equal to right side, therefore a is indeed equal to 14. So this, I'm just going to recall, is called solving one-step equations. Okay, so they're pretty simple. You can solve basically in one step, hence the concept, the name of the concept. There's also something called solving two-step equations, which means that it just takes an additional step for you to solve or to find the value of our unknown. So here are some steps for you to follow in order for you to solve two-step equations. Isolate the variable term. Isolate the variable. Check your solution. So let's try the first one. Solve the following equations. 8 minus 2b is equal to 11. Okay, so my goal is to have b isolated. Okay, which means that my 8 needs to go and my negative 2 needs to go. Okay, so I'm going to start off by removing this 8 from the left side. So what I can do is I can subtract 8 from both sides. Okay, or what I can do is I can just bring the 8 over to the other side. Now, when you bring a value over to the other side, to the opposite side of the equal sign, it always becomes its opposite value. So over here, it's positive 8. So when I bring 8 over to the other side, it's going to become its opposite operation, negative 8. Okay, it's just another way. So you can still do what we did over here, and you can subtract 8 from both sides, or you can just subtract 8 from its opposite side. So I'm going to bring 8 over to the other side, which means that negative 2b is left on the left side. And now, when I bring 8 over to the other side, it becomes negative 8. I'm not done though. I first need to simplify my right side. And now I need to isolate b. I need to eliminate our negative 2. So again, I can bring my negative 2 over to the other side. It's multiplication on the left side, so it becomes division on the right side. Or we can also just divide negative 2 from both sides. Okay, one thing to note is that we cannot leave a negative sign in the denominator. Okay, so I'm going to rewrite it. You can either rewrite it like this by bringing the negative sign to the numerator, or by writing the negative sign right in front of your fraction. And we're done. I would leave my final answer in fraction form, unless the question specifies to convert to decimal, or unless you're dealing with money, because with money we always deal with decimals, we don't deal with fractions. But if it's not a money question, or if it doesn't specifically tell you to have your final answer in decimal form, please leave it in fraction form. Also leave it as an improper fraction. Don't convert it into a mixed fraction. Just leave it in improper fraction form. Okay, let's try the next one. 8 is equal to 4w minus 3. So I'm going to bring the 3 over to the other side, and it's going to become its opposite operation. And then I'm going to simplify my left side. And then I can either divide both sides by 4, or I can just bring the 4 over to the left side of the equal sign, and it becomes its opposite operation. Again, I'm going to leave my answer in improper fraction form. Modeling with equations. At a concert fan shop, t-shirts cost $19 each, including tax. Susie bought $266 worth of t-shirts to give to her family and friends. Write an equation to model the number of t-shirts Susie bought. Okay, so I'm going to first start off by writing something called a let statement. In this let statement, you identify a variable of your choosing, which represents something in the question. So I have decided to use the variable n to represent the number of t-shirts that Susie bought. You could use x, you can use a, you can use t, whatever variable you choose. Now that I have a variable and I've identified what it represents, I can write an equation. So we're trying to find how many t-shirts she bought. So we're trying to find the value of n. And each t-shirt costs $19. So 19 times however many t-shirts she bought is equal to $266. So her total that she spent is on one side of the equal sign alone. On the other side, I have my unknown value of number of t-shirts times the cost of one t-shirt. Now in B, use the equation to determine how many t-shirts Susie bought. So now we're going to solve. So I'm going to rewrite it, my equation. Okay. And I'm going to divide both sides by 19 in order to isolate n. Using my calculator, I'm going to find out what 266 divided by 19 is, and it is equal to 14. So since this is a word problem, I'm going to complete my question with therefore statement. So therefore, Susie bought 14 t-shirts. Billy has $30 to spend at the movies. Movie tickets cost $10 without being a VIP member, or $6.50 if a customer is a VIP member. A VIP membership costs $4. Should Billy buy membership pass? So I'm going to set up two equations. Okay, my first equation is going to be without a VIP membership. And my second equation is going to be with a VIP membership. Okay. And again, I need a let statement. So I'm going to let M represent the number of movies Billy can watch. Okay. So my equation 1, without membership. Okay. So it says in the question that without a membership, it's $10 a movie. So $10 per movie, and Billy has $30 to spend. So his total amount of money is on one side of the equal sign, and then my variable times the cost for one ticket is on the other side. And now I'm going to isolate and solve for n. Okay. When your denominator is a 1, you're just going to go ahead and write it without that denominator. Okay? We don't need to write a denominator when it's 1. Just don't include it. Equation 2, with a VIP membership. Okay, so Billy still has $30 to spend. So that's going to be on one side of the equal sign. It's $6.50 per ticket, 6.5 per ticket, and then plus you got to pay $4 to be a member or a VIP member. So plus the 4, which is a one-time $4 purchase. And then we're going to add that to however many movies he can watch with his $30. And each movie is $6.50 or 6.5. Okay, so this is a two-step equation, or solving two-step equations. First, I'm going to move my 4 over to the other side, and then I'm going to divide both sides by 6.5. Oops. Subtract 4. Okay. So remember what M stands for. M is number of movies. So without a membership, this is how many movies Billy can watch. With a membership, this is how many movies Billy can watch. So to answer the question, should Billy buy membership? Yeah, he should. He can watch more movies if he is a VIP member. So since the question is presented in words, I'm going to answer in words. Therefore, Billy should buy a VIP membership. For $30, he can watch 4 movies with a membership. Oops. And 3 movies without a membership. Okay. So there are some questions here in the textbook for you to try. Number 16 is very similar to this last question that we've completed together. So please make sure that you do try all the homework questions. And then you do have your daily quiz to complete, which is based off of this lesson. And if you have any questions, message me on D2L Brightspace, or you can always email me.